Hello everyone, I hope you guys are doing good. So, welcome back to the Blind 75 series, and today we'll be covering another problem number 242, that is valid anagram. So, let's first understand what's an anagram. So, an anagram is a word or a phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So, for example, a valid anagram can be A, B, C, and C, B, A. To make it simple, a string T is a valid anagram of string S if each element or each character of string T is present in string S exactly once. So in our problem, we have been given two strings S and T, and we have to return true if the string T is a valid anagram of string S, else we have to return false. So to solve this question, we would be using uh, hash map, or as we say in Python, a dictionary. So our main approach in this problem would be to count all the characters and their occurrence first in string S, and then we'll move on to string T and subtract each occurrence of a character from the dictionary that we are keeping a note of. So, for example, in this case, we'll start with S and make a hash map, let's say hash map ds, and we'll keep a note of each character and its occurrence. For example, while looping through a string S, the first thing we'll be noting is the letter A. So here we would put A and its occurrence 1. Then to the next element, we'll put B and its occurrence 1. For example, there's another A over here. After B, we'll go on and look into C and put 1. And now we are on the index 3 and we see a again. So we'll increment our 1 and make it 2. So now after completing our first traversal of string S, the main idea is to go on to string T, traverse the string T, subtract each occurrence of the characters present in string T from the hash map that we have created here. And if each of the element in the hash map is present 0 times, then we can return that yes, T is an anagram of S. Another case could be if any other character in T is not present in the hash map, then we can straight away return false. So now we'll be traversing string T. Let's say there's a here. So first we'll go to C, the 0th index. Here we have C. So we'll go to C, we'll decrement it by 1, 0. Now we'll go to B, we'll decrement it by 1. Now we'll go to A, we'll decrement it by 1. And again A, and decrement it by 1. Now we can see, if we look into our hash map ds dot values, so we can see we have 0, 0, 0, all zeros. So as we can see, the sum of, let me call this x, the sum of x is equal to 0. If this is the case, then we have a solution. We have to return true. And for cases where the sum is not equal to 0, we return false. That means that there still exist some characters in S that are not present in T. So now we'll be looking forward to the code of our problem. So starting with the hash map, let's call it DS. A hash map is also known as a dictionary data structure in Python. So our first job is to traverse the string S. So we'll say for character in S, if the character is not present in a hash map DS, then we'll give that character a value of 1. This means that, yes, there is this character and this is present once. Else, if that character is already present in a hash map, we'll just update the value of a character by 1. So after first traversal, now we'll move on and traverse the string T. So for C in T, for characters in T, if the base case, if the character, let's say C, is not in a hash map, that means a certain character present over here, let's say it was X, and here we have another A. A certain character X over here, and if it's not present in a hash map, then we can straight away return false, as we have a character here which is not a part of S. So if C not in hash map DS, will straight away return false. LF, the count of character C is greater than 0. That means the occurrence, there is at least one occurrence of the character C in a hash map, then we will just decrement the count of that character by 1. Else, we would just return false. Any other case, like for cases we were discussing about, if there still exists a character even after traversing, and like the main case over here is if we have the count of character greater than 0, it means that we can subtract or decrement the count by 1. But if the count of that character is already 0, means we have used all the present characters. For example, say A is here twice. And if we have A here thrice, and when we are at our final element and we see that all the A's have already been used, now we cannot go and decrement it by 1 and say -1, because we have an extra character over here. So for such cases, we'll straight away return false, that we have an extra character in string T. Now, after completing both of our traversals, we would just return true if sum of ds dot values is 0. That means there are equal number of characters in both the strings, or string T is an anagram of string S. Else, we would return false. Let's check our solution. So we can say it's pretty efficient. It's beats 88.2% on runtime and 91.21% on memory. So in this solution, as we can see, the time complexity as we uh, are traversing two strings, and let's say if they are anagram, they'll be both of length L, so it will be 2n or O of n plus m if they are two other strings, and it can be concluded as O of n, and the space complexity would be O of n, as we're only keeping track in our data structure hash map.